Lesson 18, student page 101. Consider the equation quantity x plus 3 divided by quantity x minus 2 equal to 5 times the quantity x minus 2. This is an interesting question. It says rewrite the equation into a system of equations. Well, remember, we have to check for zeros, but we can always start with the equation itself. So x plus 3 over x minus 2 is equal to 5 divided by the quantity x minus 2. And nice thing about this problem is that both denominators are the same. So the only thing we have to check and make sure we don't mess up is that x minus 2 equals 0 is not true. And that means it's good as long as x does not equal positive 2. There's our system of equations, 1 and 2. That's enough. 2 is the system. Solve the equation for x excluding the values of x that lead to a denominator of 0. As long as x does not equal 2, this is very interesting. If you look at this, if you think about it, and this is really quite nice, this problem is simple. We have x minus 2 in both denominators. That means the two numerators must match. And we can quickly go in here, x plus 3 equal to 5, and find our answer, x is equal to 2. Bada boom, bada bang. X can equal 2, but x does equal 2. Oh no. Oh no. Oh, that's not what we want, is it? Well, the problem is because that's not what we want. If the only answer we want is the only answer we can't have, we've got to say no. Have some new equations to work on. Rewrite each equation into a system of equations excluding the values of x that lead to a denominator of 0. Then solve for x. Well, we don't want to let x equal 0 in this one, so we'll say no. Over here, we don't want x minus 5 to equal 0, which means x can't be 5. All right, we've excluded some values here. Ooh, that x just got bad all over. Hold on, let me see if I can make that look a little better. We excluded the values from the denominators. And now let's take a look at how easy it is to solve these. Honestly, if you have 5 over x equals 1, you could cross multiply, but you could also consider just multiplying both sides by x. And if you do that, what you get is you get a 1. Here's a nice 1. We love 1s. And 5 equals x. Well, 5 equals 5 also, but really we want 5 to equal x. There we go. So we have some answers. 5 equals x, but we must exclude the possibility of x equaling 0. Now, actually, we can pull the same trick here. 1 times the quantity x minus 5 equals 3. If I want to be really ingenious, I can multiply both sides by the quantity x minus 5. And since it's not a denominator number, I have to think of it as a numerator. Whoops, not 3, 5. Just wrote a 3, that's why. Okay, 5. There we go. All right, so what we see is let me get a slasher. Red's good for slashing. Those two equal 1. It's a nice 1. X minus 5 over x minus 5 is 1. 1 equals 3 times x minus 5. 1 equals 3x minus 15. Let's go ahead and add 15 to both sides. Plus 15 plus 15. All we get is 16 equals 3x. We start to get nervous. We don't like it, but you know what? I don't think we made any errors. So I think we just go ahead and go with divide by 3 and accept what we have for an answer. There's a 1. And we get 16 over 3 equals x. All right, a fraction. I feel better once in a while when I get a fraction. I mean, after all, I've told you, there's a lot more fractions than whole numbers. All right, let's see what's... I'm only going to do one more of these, and I want you to try the other 3. And I'm thinking, I think probably they'd like me to do this one. So let's go ahead and check. We know x plus 6 cannot equal 0, so that means x is not negative 6. Good with that. But again, here we have a situation where we have a common denominator. Now, last time I told you we could just say x equals the opposite of 6, because if both numerators should be equal to each other, remember that negative can float top because we matched the bottoms. But maybe you'd like to see this just one other way so I can prove to you I'm right, or you're right. So what if we multiplied both sides by x plus 6? So, okay, yeah, this turned out way messier than I planned. So let's go ahead and I'm going to write this. X plus 6 times x over x plus 6. That's what this side looks like. And then equals negative 6 times x, oops, missed a parenthesis, plus 6 over x plus 6. Now, even with parentheses, we have 1s. So what we have is a couple of pairs of very obvious ones. Here's a 1, and here's a 1. Well, no matter how hard I tried, I gotta tell you, all I have left is x equals negative 6. Oh, goodness, what have we done? We've got ourselves into another situation where the only answer we have is x equals negative 6, but, oh no, we're not allowed to have negative 6. That means no solution. Again, darn it. Hate it when there's no solution. I like answers. Okay, well, I don't hate it. Yeah, I do. It's frustrating. All right,